Hi, this is Chris Poor with Assured Information Security, and in this video I'll be going over the Protocol Discovery tab. This tab is designed to take your target signal of interest and start to demodulate it, figure out the bits, what protocol it belongs to, so that you can do attacks, or you can try to reverse what it's doing and kind of build out your library of signals and protocols with more information. Maybe you want to figure out what certain messages are, or what certain fields are, or CRC values and things like that. So you would start out selecting a signal of interest, start off the protocol discovery. That's what this button does. This is kind of just meant to give you a status view of what's going on. Since it doesn't do very much at the moment on its own, there's not much being reported here, so it's not even really worth looking at too much. But once you have your signal, maybe you have certain criteria that you want to use from that TSI component, like you identified a protocol maybe of interest, or maybe you found a modulation type or just a frequency value. So like if I have on-off keying or something, you can search your library and find a flow graph to run on a new radio, on a different radio. So if I have a B210 going, it will show me in this tab all the different demodulation flow graphs I have. I don't have very many right now, but what's going to happen is in the future, instead of just loading something that takes a signal and prints out bits, I'm going to load a flow graph that tries to figure out more about the protocol. So it may at first try to see if there's a certain modulation type going on. It may cycle through and say, is this FSK? What's the frequency deviation of the signal? How confident am I that it's FSK? Is it on-off keying? Is it going on and off at the same frequency? Is there a preamble and stuff like that? Is there just like a burst at the beginning to kick it off, and then it goes into the rest of the message? Is there something at the end that's always the same? Is there a CRC going on? So yeah, it starts off with knowing nothing about your signal. Then you measure certain signal parameters and you use them to build a confidence to load another flow graph. So you take the output, once you're confident enough, feed it into what you measured into a new flow graph, learn more about it, repeat the process till eventually you can choose with some level of confidence a demodulation flow graph. So it'll recommend a flow graph for you. So if I select, I have an X10 remote here. So if I load a flow graph, hit start, what it's going to do when I press on this remote here is it will print out different messages in the terminal there. It'll demodulate it. But what's also going on is that it's feeding those messages into a circular buffer. It just gets populated with one big bit stream. Let's stop that. So as I press each button, it can demodulate the bits, and it'll put them in one big stream for me to process. But if I already know what's going on, I can also just, see output here. And what the idea is, if you have an unknown protocol and you're just working with a bit stream, I mean, it's good to just get there. That's a lot of work to get there. But once you're there, how do you figure out what's going on from those bits? So right now there's just a basic preamble search going on. So if you have things that are the same lengths, you can get statistics on what's going on in that stream. So if I just hit 5 preambles, I can change the length of those preambles, but it's the top hit is 609F is what each message starts with. And there's so many occurrences and there's different values here, which may or may not be the most accurate thing in the world. But you would take this value and you could slice that circular buffer by things that begin with that preamble, and you return to the dashboard. So there's 36 occurrences, and you say, give me the first 20 that I see. And what you're going to see is the printout of those 20 messages. They're not all going to be the same. Some will have different lengths, maybe. Maybe I got one at the end, or some bits got cut off or something. But you can do different operations on all these messages. You can slice them up. You can look at them on the hex or binary. You can combine things, shift, merge fields, plot entropy. So if certain bit positions are doing the same thing, they're all going to be 0. And if they're changing values all the time, they're going to be higher. So you can kind of see, like, the beginning's all the same, and the end here and the very end is kind of the same. So there's something going on in the middle. But as you kind of figure out where those fields are, you can divide up your messages here and add them to your library. Let's see, like I have an X10. I got a new packet type. It'll automatically populate these fields that I found, and I can rename them to, whatever I want, and give them different default values and save them in my library. So later on, when I'm looking at my library of X10, I can see different packet types, or different protocol, different packet types. We'll get into those tabs later. But that is the idea of protocol discovery. You go from a signal to a bit stream that makes sense, and you add it to your library. So you discovered an unknown protocol, and you now know it. There's a lot that goes into it, and there's a lot that's not here, but this is just the basics. This is a starting point, and the most work is going to be in this automatic recursive demodulation going on. That has to be done. But there are a couple things that do exist. So if I take a message, like here, a hex message, there's a data viewer. I can paste a couple different messages. I can convert the binary, go back to hex, view it in ASCII. Certain programs will just spit out bits for you, and you don't really know what they are. So this is kind of helpful if you want to invert, do Manchester encoding. If you don't do it right, you're obviously going to get question marks and things like that. There are other programs out there that do this. I've seen them, but this is all in one place. You can do it here. Another feature is that if you have lots of messages, you can copy and paste them here, and you can fill up this table, and you can apply it to protocols already in your library and see how well they fit. So if I have an X10 message, which I do, you'll see an address code and an address code inverse, which is just the opposite of these bits. It's the same thing with the data code. So you can see it matches up perfectly, and there's no extra bits going on. You can convert them to hex. So if you had a program that cycled through all your protocols and kind of went through all your messages and sees how well these things match up. Maybe it checks for these inverses, or maybe it checks for a CRC field or something. And you can assign a confidence. So if I say, is this a TPMS signal? And hit apply, you'll see that it doesn't fill out these fields. So it's not a good match for that protocol and that message type. So you can give it a low confidence. It's not a TPMS signal, and it is an X10 signal. So building the smarts to automatically do that, it's not here yet, but you can. It wouldn't take that much to do what I just described to you, to just cycle through all those things. It may take a lot of time, but I don't think it'll take much programming. That's the data viewer. I do have the dissectors that you could make for Wireshark, custom ones, custom Lua dissectors. So if you want to make one from scratch, you hit new. I'm not going to do this because you kind of have to know a little bit about what's going on with Wireshark Lua dissectors. You can select your types, your base, your bit mask, what fields, positions each field is assigned to, which bits. So if you don't know how to do any of this, you can read up on it. There's a lesson about it. Lua dissectors. I won't go over this right now, but there are examples of what I'm doing, or what that table does when you click save and stuff. So we'll go over that later. But if you want to see them in action, what they're doing, there's a Sniffer tab. So whenever you create a dissector, it gets assigned a UDP port to it. In the future, that might change, but for now, each unique packet type is assigned a UDP port. So when you run it in your sniffer here, select the protocol. If there's an available sniffer, it will be an option at a port. When you launch it, it'll kick off Wireshark. It'll run a flow graph, which kicks off Wireshark, and you can select a filter. It'll automatically know my protocol here because I made a dissector for it. And when you're doing that demodulation, if I kick it off again, producing these bits and these messages, it'll feed it into Wireshark at that UDP port that I assigned to my dissector. So I think it's going right now. And I click the button on my remote, and there you go. I get custom Wireshark messages sent to me. And in each one, depending on how I set it up, you can see the different values. And they change depending on what button I was pressing on my remote. But that's not all. Let's stop that. You can also just send binary data to that port from a file or something. So if you saved off a packet and I have a X10 message, I send it to that port, click send it a couple times, and it gets there. So if you want to test your crafting skills and see how well it matches up to your dissector, you can do that. Or if you want to send a different message, like you send a TPMS message to that port that's going to apply the X10 dissector. It's not ideal, but you'll see that it doesn't match up perfectly. It's got extra bits at the end. You can do it. It'll accept whatever data you send it. Okay, so that's what the dissectors in Sniffer tab does. This will just launch Wireshark. This does a netcat listener for nothing in particular. it'll get filled out once I start to use more things. The last tab in protocol discovery is the CRC calculator. It's kind of the same thing you see online. You can choose how big you want the CRC. You can choose different algorithms, and it'll automatically assign polynomials and XOR values and reverse data or not. And you click calculate, spits out the CRC for whatever hex you give it. But you can also do kind of a reverse lookup where you give it the message and the two known CRCs for two different messages, and you hit start. It'll cycle through all the combinations and give you the polynomial based on your data, which is good for reversing messages that you demodulated, but you don't know what the algorithm is for the CRC. But you have those bits already, so you can just plug them in here. And it does work. I have used this before to get like TPMS CRC values and stuff to make sure that they're right. And that is protocol discovery. Once you're here, the information you've gained will go into your library to be used for packet crafting, for doing attacks, and things like that. So if automation was enabled, it would feed in inputs from TSI, go through target signals of interest, spit out information about the protocol as it gets discovered. And if you get all the way to the end, report back results. And if it's an unknown protocol, add it to your library or add pieces of it to your library that you think you know. There's a lot of work there that still has to be done. But, each area has its own specific field. I mean, there's a lot that you could do for each aspect of this. But that's the idea. And the other videos will go over packet crafting, the library attacks like you did. We'll go through all that.